This is the answer here. So this way you can solve the question, not a difficult one, you can do it. Now coming on second topic. In second topic we are finding approximate value. Approximation we are doing, approximation by using the derivative. Approximation with respect to the derivative by using derivative. One thing we have already done here, delta y by delta x, I told you average change in y with respect to x. And dy by dx is simply instantaneous change in y with respect to x. These are the two things we have already done. And on the graph, I already told you that the slope of this chord is delta y by delta x. And when you take delta x approaches to 0, at this point it will become a tangent. So that is dy by dx. Slope of this line is dy by dx. Slope of the chord is delta y by delta x. And if you take delta x is a smaller one, ये delta x अगर आप बहुत छोटा लेंगे तो ये आपकी chord और छोटी हो जाएगी. And you will find that these two are going nearly same. ये difference धीरे धीरे कम हो जाएगा. और छोटा करो इसको, ये difference आपका और कम हो जाएगा. इसका मतलब these two can be nearly same if you take delta x as very small. Average and the instantaneous will become nearly same if your delta x is very small. So that means one thing I can say now, delta y by delta x is nearly equal to dy by dx. Okay? Delta y by delta x is nearly equal to dy by dx. And that means there is a slight difference coming between the two. Just to get the slight difference elimination, what I do here, let it will be dy by dx plus some more number. Because you told that there is a slight difference. So difference means there is a difference, that difference we have added on one of the side. After getting this, epsilon is some positive number which should be very small depending on what? Depending on delta x. If delta x is small, definitely epsilon is also small. Epsilon is the difference between them. Now from this I can say delta y come out to be dy by dx into delta x plus epsilon delta x. Now I told you that this is a very small quantity, as well as this is also very small quantity. As this is small and this is also small, and if you multiply the two, it will become more small. And when it will become more small, I say that in comparison to this number, this will be negligible. And then we can write delta y is dy by dx into delta x approximate. We should know this. This is the formula we are going to have for approximation. Approximate change in x I do. What is the change comes in y? We will be calculating. एक वेरिएबल हम चेंज करेंगे, दूसरे में कितना चेंज आ रहा है, that we are going to calculate. That is called approximate change in y with respect to x. Now one more thing note here. Delta x we call as absolute error. Delta x by x, if you take, it is called relative error. And when you have delta x by x into 100, it is called percentage error. These are the three terms also we should remember. Delta x stands for absolute error or absolute change. Absolute means I am not taking plus and minus. Delta x by x means initial क्या थी, उसमें कितना change किया, that will be called relative error. जैसे आपने 25 है और 25 में 25.2 कर दिया, तो that is an error you are creating as 0.2. So 0.2 with respect to the actual, that is 25. And if you take delta x by x into 100, it will become percentage. That also you should do. So delta y is this, delta y is this is the approximate formula I told you. We are going to use it. How we are going to use in few questions, I'll tell you. Simply, if I say you find out value of under root 36.2. 36.2 under root I have to calculate. When I say under root 36.2, one thing is clear, I know under root 36, very simple. That is 6. But when we say 36.2 and under root, then calculation will be slightly difficult, and we should calculate this new value by using the derivative. Now, one thing also you should keep in mind, this value will be coming nearly correct. Why it is correct? Because the error which you are creating is 0.2 in comparison to 36. 36 आपका comparison में अगर 0.2 आप लेंगे तो very small quantity. That means delta x is very small. And if delta x is very small, this formula is valid and it will be giving nearly an accurate value. If delta x will be bigger, the error will be more. Delta x is less in comparison, we'll say we are going to the accurate value. Now, whenever this type of question comes, one thing we should decide, what is the function involved in it. So let us consider the function y is equal to, function which is involved is root x. It is clear. And here we will assume this. Let x is 36. Initial value I am saying 36. And the new value is 36.2. What does it mean? Delta x comes out to be 0.2. So this is the thing. Yes?
सर approximation अभी वाले एग्जाम्स में आएगा?
नहीं, ये आपको केवल मैं एक एक एग्जांपल देके इंट्रोड्यूस कर रहा हूँ, बाकी हमारे को नहीं करना है. बट क्योंकि इंक्रीजिंग डिक्रीजिंग में कहीं कहीं यूज हो रहा है तो वी शुड नो इट. ये कॉन्सेप्ट मुझे आनी चाहिए. ठीक है, तो एक एक एग्जांपल आपको करा रहा हूँ, बाकी ज्यादा नहीं. So x is coming 36, x plus delta x will be 36.2, delta x is coming 0.2. Then I go for dy by dx. What dy by dx? Derivative when you do it will be 1 by 2 root x. And this is the change, instantaneous change taking place at 36. So I go for dy by dx. When x we have 36. ये कितना आ गया 1 by 2 root 36. 6 into 2 will be 1 by 12. And then we have done, what is the error is there in y? You have created error of 0.2. What is the error in y? We are calculating now. Formula already I told you, it is dy by dx into delta x. dy by dx already we got 1 by 12. What is delta x? 0.2. So it will come out to be 0.2 by 12. That means it will be 0.1 by 6, or I should say 1 by 60. Solve it please, what this value comes. Point is there, so 1 0. Another point is there, 1 more 0. 60, 1s are 60, left is 40. So 1 more 0, 6, 6, 36. So 0.016 is the error we have delta y. Now they are asking what is the final value. Final value is actually y plus delta y. Y was what? Under root x. Under root x means under root 36. Delta y I got it 0.016. So that means you take 6.016. You can use the calculator, the answer will come out to be this one. Because the error is very small, so that's why we will say the accurate value are good. So this way you can have these questions also, error and approximation. So one question I told you, more question I am not going to do. Write down now. Next one is Rolle's theorem. Next one is Rolle's theorem, or first you take mean value theorem. Mean value theorem. Topic you take mean value theorem, and then in that first one is Rolle's theorem. Mean value theorem. In that first one, the Rolle's theorem. Write down definition of it, please. Let f be a real valued function. Let f be a real valued function defined on closed interval AB. Let f be a real valued function defined on closed interval AB. Okay, such that first condition note here, fx is continuous on closed interval AB. The function which you have, that is clearly continuous on closed interval AB. Second condition, it says fx is differentiable on open interval AB. And third condition is fa is equal to fb. These are the three conditions a function must satisfy. We are having a one function. One function we have, real valued function on defined closed interval AB, where function is continuous on closed interval AB, differentiable on open interval AB, fa is equal to f. Then, if these three conditions are satisfied by a function, then there exists a point C. There exists a point C belongs to open interval AB such that f dash C is coming here. If any real value function is given to us, satisfies these conditions, that function should be continuous in closed interval, differentiable on open interval, fa is equal to fb we have. So these three conditions are satisfied. We say Rolle's theorem is applicable. And if it is applicable, then there exists a point C belongs to AB such that f dash C has to be 0. Now, what is the meaning of it? This, why we are taking this? What is the meaning of this? That also you should understand. So, by the graphical way, I am telling you. So, please note it fast. Now what it says, just check here. One real valued function is there, means it is going to take real values. Whatever x you put, you will get a real value. X is equal to a is this point, x is equal to b is this point, and in between you have this function. fa is equal to fb given. So at x is equal to a, whatever the function's value, the same value at b also. So that means this point, if I take, it will be a and fa. And this point, it will be B and FB, and FA and FB are same. A and B are different, but the A and B, FA and FB are same. First says the function between A and B must be continuous. Continuous means the curve which we are going to plot will be without a break. Okay, it should not be broken curve. Second thing, function is differentiable on open interval AB. When I say it is differentiable means there must not be any corner point. बीच में कहीं corner point नहीं आना चाहिए. That means the curve which you can plot will be like this. It is a continuous curve, no corner point. This curve can go like this also. There is no corner point. Continuous here. This can have this way, no problem. When we have the curve like this, there is no problem. Any other point if you take, this is no problem. Any shape you take, but keep these three things in mind. That FA is same as FB, means they will start from the same height and end at the same height. Second thing which I told you, it should be continuous. Differentiable also means this type of curve should not come where the corner point is there. We should not. Now these three conditions are satisfied by a function. Then what this theorem says, there must be a point C in this interval. Definitely there will be a point C in this interval where if you draw tangent, that will come, C is a point on AB such that f dash C is equal to 0. Means slope of tangent at C 0 means it will be parallel to x-axis. So I have a tangent parallel to x-axis here. This is the point C. If you take this curve, there are so many C. 1, 2, 3, 4, 5. 5 tangents are there where the f dash C is 0. On this curve, 1, 2, 3. 3 points are there where the tangent is becoming parallel to x-axis. This is another one where the tangent will become parallel to x-axis. And in this case, every point you take, the tangent will come parallel to x-axis. So when you have a function which satisfies all the three conditions, there will be a point on this curve where if you draw tangent, that tangent will be coming parallel to x-axis. This is our Rolle's theorem. Is the Rolle's theorem clear? If the function is continuous, it is differentiable, f is equal to fb, then there will be a point C on this interval AB where if you have tangent, that tangent will be parallel to x-axis. That we should keep it. So this is our Rolle's theorem.